Now we take resistors in parallel. The parallel arrangement can be something like this. I have two resistors connected in parallel. So we have two resistors connected in parallel. This, for example, is R1. This one is R2. Here, the equation is different compared to in series. Here in parallel, we have to take 1 over R equal to 1 over R1 plus 1 over R2. This R gives me the total, the effective resistance. R1 will be for this one, R2 for this one. So this is the equation for resistors in parallel. So if I take, for example, here 10 ohm, here as well 10 ohm. So when I calculate now 1 over R equal to 1 over 10 plus 1 over 10, this gives me 2 over 10 or 1 over 5. So you have to remember 1 over R equal to 1 over 5. It is not R equal to 1 over R, but 1 over 5. So 1 over R equal to 1 over 5. So R gives me 5 ohm. So you have to take the reciprocal. For example, 1 over R, 1 over 5. So when you take reciprocal, you do the inverse of it. So R will be equal to 5 ohm. So in parallel, you have to write the equation first. Then you substitute the values, then you do the calculation, and as usual, there should be an SI unit. Now, just remember one thing. When you have two resistors having the same resistances, for example, 10 ohm, 10 ohm, the total or the net is simply 10 divided by 2. How? I have both of them 10 ohm, 10 ohm. I have two resistors. I take one of them because they are identical. They are the same. I take one of them. Then I have two resistors, so it becomes 10 divided by 2 give me 5. Similarly, if I have three resistors in parallel, for example, if I take three resistors in parallel, 10 ohm, 10 ohm, 10 ohm. Now in this case, the equation becomes 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3. 1 over 10 plus 1 over 10 plus 1 over 10, 3 over 10. 1 over R is 3 over 10. R is 10 over 3 because I have to take the reciprocal. This gives me 3.33 ohm or 3 1/3 ohm. Now, this is the equation, the substitution, the final answer. Now, because you have three identical resistors, so what will be the total? You take one of them, 10, 10, 10, you take only one of them. Because you have three resistors, you divide by 3, this gives me 3 1/3 ohm. So, when I have three resistors in parallel, they are identical. I take one of them, I divide by 3. Similarly, if I have, for example, 5 resistors in parallel, for example 5, I take 10 divided by 5 gives me 2 ohms. This is the way to work out the parallel resistors. Now, it's not always that it will be having identical resistors. They may be different as well. So if I take, for example, here, I take 5 ohm, and here I take 10 ohm. They are not identical. So I have to proceed with the equation. So 1 over R equal to 1 over R1 plus 1 over R2. So this gives me 1 over 5 plus 1 over 10. So 1 over R, now you have 5 and 10 here. You have to calculate the LCM. So 1 over 5 becomes 2 over 10 plus 1 over 10. So the same LCM, the LCM is 10 here. So this gives me 3 over 10. So R equal to 10 over 3, as usual, the reciprocal, because 1 over R equals 3 over 10. So R becomes this 3 1/3 ohm. So this is the arrangement when we have two different resistors. So another example I take. Now the diagram can also be like this. I can play these two in parallel like this. For example, I have here 20 ohm and I have here 40 ohm. They are in parallel. It's simply the arrangement in a vertical plane now. So 1 over R equal to 1 over 20 plus 1 over 40. So the LCM here, 20 and 40, the LCM is 40. So 2 over 40 plus 1 over 40. This gives me 3 over 40. And R becomes 40 over 3. Give me 13 and 1/3 ohm. So this is how we proceed with calculation in parallel. Now you may have arrangement where you may have series and parallel together. So I'll take one simple example. For example, I take this one. I have one resistor here and I have two in parallel. I put everywhere 10 ohm. So 10 ohm everywhere. Now these two resistors, they are in parallel. I should calculate this one first. When you have such an arrangement, you have to calculate for the parallel first. For example, 10, 10 in parallel. I've just shown to you. If you have two identical resistors, 10 and 10 ohm, they are in parallel, the answer will be 5. 10 divided by 2. But I have to show in my calculation how it is done. So 1 over R equal to 1 over R1 plus 1 over R2. This makes me 1 over 10 plus 1 over 10. This gives me 2 over 10. R equal to 5 ohm. So for this part of the arrangement, I have 10 ohm in parallel. I have 5 ohm. Now this 5 ohm that I get here is in series with this 10. So now in series is R1 plus R2. To calculate the total, you just have to add the resistances. So here it's 10. Here the arrangement is 5. So this gives me 10 plus 5. This gives me 15 ohm. So whenever you have such an arrangement, you have to calculate for the one in parallel first. Then you add with the one in series with it. So you have 5 here. You have 10 here. You get total 15 ohm. Now, another arrangement, for example, I may have something like this. I have 20 ohm here. I have 20 ohm. I have 20 ohm. In this arrangement, you have to calculate the total of the resistances in parallel. In series, not in parallel. So you have 20, 20 in series. The total gives me R equal to R1 plus R2. 20 plus 20 gives me 40 ohm. So I calculate for these two in series first. 20 plus 20 gives me 40 ohm. Now this 40 ohm will be in parallel with the 20. So 1 over R equal to 1 over 40 plus 1 over 20. So where I got the 40? For these two in series, I calculate the total, I get 40. Now this 40 is in parallel with this 20 ohm. So 1 over 40 plus 1 over 20 equal to 1 over R. So as usual, you have to calculate the LCM. Here 1 over 40, here 2 over 40, giving me 3 over 40. R equal to 40 over 3. Now you can evaluate 13 1/3 or 13.3 ohm.